Hi, Libby. This is section 4.4. We took a quiz yesterday, so we're trucking right along. 4.4. 4.4 is going to be very, very similar to 4.3. It's just the same process except with two different ones. And so I'm going to talk through that. I'm going to write some stuff up here, yeah, we'll just get going. So in section 4.2, when we very first started talking about triangles that are congruent, okay, we would have to check all three angles. And we would have to check all three sides to make sure that they matched up. And after we checked them, and we did all 6 of those things, then we were able to say that this triangle was congruent to this triangle, okay? But now, since then, we have learned shortcuts, okay? And one of the shortcuts was side, 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 because we said that if this side matches this one, and this side matches this one, and this side matches this one, there's no way that the angles could be different. Like that has to match up, and those two triangles have to be congruent. Even if I rotate him around, he's still going to be congruent, right? Like maybe this one's upside down, but the sides are still matching up, right? Like maybe this is happening, but those two triangles are still congruent. If the sides match up, the angles have to match up. Now that's not true if we have all 3 angles matching up, like angle, angle, angle. Let's say we have an equilateral triangle here where all of them are 60s, and we have an equilateral triangle here where all of them are 60s. Those are the same shape, but they're not the same size. So AAA does not work. Side, side, side does work. Angle, angle, angle does not work, okay? The other one that we learned was side, angle, side. So let's say we have a triangle here, and we're trying to prove that this triangle is here, that they are congruent. And we know that this side matches this one and this side matches this one. Which angle has to match? The one in between them, right here. So if that happens, then we don't necessarily know that this angle matches this one, and we don't necessarily know that this angle matches this one, and we don't necessarily know that this side matches this one. But if they give me the other stuff, whoop, QuickTime Player quit unexpectedly. But it's still going. Okay, whatever. If they give me the stuff in orange, they give me those 3 things, the green things have to take place. Those just have to happen, right? So there's no way of drawing these triangles and having the 3 things happen, but the other 3 things not happen, okay? So we have those 3 shortcuts, right? Okay? Now, let's talk about different combinations that we could have, okay? So we've talked about side, 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 okay? Then we've talked about side, angle, side. Other combinations would be like side, side, angle, right? Or this way. Where this way?
I know, I just like how she deliberately put it in that order.
Right. Side, side, angle, or what's the other one? Angle, side, side?
Angle, side, side.
Angle, side, side, okay.
Now she's laughing. I'm sorry. It's Angel being inappropriate, not me, Libby.
If I wasn't recording, I would do like a kind of an inappropriate joke right now. Okay, so don't listen to this, Libby. So you know what this word is?
Yeah.
Do you know what this word is?
Saw.
Ass backward. Anyway, okay. Woo, okay. All right, here we go. Then we have angle, angle, side. We have angle, side, angle, and angle, angle, angle. Did I get all of them? No, we're missing one. What one are we missing?
Side angle, angle.
Side, angle, angle. There we go.
We're so good.
SAA. There we go. We're missing those. Okay, so there's all 8 of them. Those are all 8 combinations that we could have. Yeah? Okay. Okay, so we have done this one and this one already, and we said that those work. Those check. If we're able to say that those are happening, then the triangles are congruent. Okay? Today, we're going to be doing angle, side, angle, and angle, angle, side. So those check off, right? Okay? Now, technically, this one, let me circle this one. This one, SAA, is the same thing as AAS. Do you see that? Mm-hmm. So, that's kind of like a 5th one that does work, but it's the same thing as AAS. Does that make sense? Okay, so we have 4 of them that work. All right? We know that AAA does not work. Do you remember why AAA does not work? I just said.
They can be different.
They can be like equilateral triangles, so the same angles, like this angle matches this one, this angle matches this one, this angle matches this one, right? But different sizes. So that does not work. And then these 2 are the same thing, right? ASS, we said, does not work. Let me show you why ASS does not work. Here's my example. You don't necessarily have to draw this. Okay, ready? Here's ASS. Okay, so let's say that Yeah, let's do this. Let's say that I have this happening here, right? Here's my angle. Okay. Let's say I have this angle and this side, and then I have like this side. Okay? Good? All right. Now, I'm going to do the same thing again. So I'm going to make this angle, right? This angle matches. Let's do that better. This angle matches, okay? This, my sides aren't the same length. Here we go. This side, that's about the same length. But instead of doing this right here, I'm going to rotate him down here, and I'm going to do that. Do you see that? Okay, do you see what I just did? So this side is the same length as this one. The angles are matching up, but this third side, instead of having him up high, I rotated him down from here down to here, and he's still the same length, but are those two triangles congruent? No. So that would be like the description of ASS, right? Angle side side. That does not work, and that's the reason why it doesn't work. Because you could draw two different triangles where the ASS is matching up, but they're not the same, correct? Yeah. Okay, so those two do not work because ASS and SSA are the same thing, so those are bad. We can't use those, right? So we really have 4 of them that work, right? These two and these two are what we're going to learn today. Okay. All right. So we have angle side angle congruence, and let me show you what the picture looks like. Okay. We have 2 angles and the side in between them. Okay. So if this angle is matching and this angle is matching, it has to be this side in between, right? Okay. So I'm going to draw a different way. Let's say I have this one and this one. Which side do I have to have? The one in between, this one right here. That's the one that I'm focusing on. That is angle side angle, okay? We also have another one that's angle angle side, okay? That's the second one that we're learning today. We have angle side angle and angle angle side, okay? If we're doing angle angle side on this one, which side do I need? If I'm doing angle angle side. Okay, let's say the bottom one. If I do the bottom one, is that angle angle side? Yes, okay, but what happens if I did this one instead? Is that angle, angle, side? Yeah, right? Now, technically, this one, if we're going clockwise, is side, angle, angle, right? But isn't angle, angle, side the same thing as side, angle, angle? Those two things are the same thing, okay? So, it doesn't matter which side you use. They're both angle, angle, side. Make sense? Okay, let's go down here. For our proof, we have this picture. And we're given some stuff, and we've got to figure out what we have and what we need. Okay? So, no, I don't think so. I don't think so. Okay? All right, so let's write down our first piece of given information. It says that QS, which is a side, it is bisecting, or bisects, angle PQR. That's given. Okay, that's my first piece of given information, all right? And I'm going to cross him out. And before you write the second piece of given information, let's write what that means. That doesn't give me anything right now. Like, that doesn't give me anything. But I can look at the diagram and figure out what that means, okay? So if QS is bisecting, this guy is bisecting this angle right here. So it's splitting that. What do we know? If this guy is splitting this guy, it's bisecting it. That means it's splitting it in 2, right? This top angle is going to be the same as that bottom angle, right? Okay, so let's name that top angle. That top angle is called angle PQS is congruent to angle. Let's go RQS. PQS and RQS. How do we know that that's true? Because it's a bisector. So that we'll call definition of angle bisector. Okay, it is bisecting angle, so by definition of angle bisector, there is that. All right, we haven't written anything down in the inventory yet. Inventory. Okay, all right. This first piece of information doesn't tell me anything yet. But from that, I was able to get this, and that gives me a angle. That gives me an angle. Okay, now let's go back to the given. Okay, back to the given. Angle PSQ and angle RSQ. PSQ is this angle here, and RSQ is this angle here. So those two are matching each other. Okay, let's write that down. Angle PSQ is congruent to angle RSQ, and that's given. Okay, and that gives me something, right? That gives me an angle, right? So we only need one more thing to match up in order for this to work, all right? So the two options that we have is we need either another angle or another side. But if we do another angle here, that's AAA, and that's one of the ones that doesn't work. So we know that we need a side, right? Okay? So which side can we pick on and say that they are exactly the same? SQ, right? The way that it's set up, so you could either do SQ or QS, it doesn't matter, right? Does it matter?
See, it says QS.
What do you mean?
In our notes.
In your notes it says QS?
QS bisects BQR.
Oh, they do call it QS. Okay, whatever. We'll do QS. We'll do QS. QS is congruent to QS. So the top QS is congruent to the bottom QS, right? The QS for the top triangle is the same as the QS for the bottom triangle. What's that called? That's the reflexive property. Reflexive property. Okay, and that gave me a side. So in my inventory, it looks like this is angle, angle, side, but let's go to the diagram. Is it actually angle, angle, side? If I look at this top triangle up here, I'm hitting an angle, and then I'm hitting a side, and then I'm hitting an angle, right? So this should be angle, side, angle, right? Don't just look at your inventory and say that that's the way that it goes. It is angle, side, angle according to the triangle, or to the thing. And we can write out angle P, or triangle PQS is congruent to triangle RQS. And that is done. Good? Happy with that? There you go. Okay. All right, now we're going to go to the back side. We're going to do a proof on the back, which is kind of similar.
And we're done.
And then we're done. Yeah, example 3. We're going to skip example 4. So just FYI, because it's just the same thing again. So just 2 proofs. All right. Now, this diagram is kind of a little confusing just because he has 2 triangles in this, okay? So, actually, I see like 4 triangles. Do you see 4 triangles? I see a ton of things going on. You see like the 2 tiny little ones? So let's talk about, let's go over here to the proof and let's see which ones we're talking about. Triangle ACD. ACD. So this is one of the triangles that we're looking at. All right. To unconfuse myself, I'm going to take ACD and I'm going to draw him over here by himself and like separate them. Okay. ACD, that's one of the triangles that we're looking at. So I'm taking him and I'm moving him over here. Okay. Then the second one is ECB. And ECB is ECB. And that's that one. Okay. So I'm going to take him and I'm going to redraw him over here as well. Just whatever. ECB. There he is. Okay, good. So I'm separating him out. That way we can mark him and he doesn't get a little, so confusing. Okay, so there he is. All right. ECB. There is those. We separated him out into 2 pieces. Okay. Let's start with the given stuff. Okay, so we are given that angle DAC is congruent to angle BEC. That's given to us. And then let's mark it on the diagram. DAC is this top angle right here, and BEC is this bottom angle right here. So we have those 2 are matching up. Okay, now this is what I don't understand. This is what I don't understand. When they give that to us, they give us 3 letters. Why can they just have called it angle A? There's only one angle A, right? And there's only one angle E, right? They could have gotten away with just calling it angle A and angle E probably, right? Yeah. Okay, so I don't know why they named it with 3 letters, but anyway, there's that, okay? Because there's only one angle A and one angle E, so there's that, okay? But anyway, whatever. That gave me, in my inventory, that gave me an angle. So we have an angle done, and that's our given. All right, then the next piece of given information we have is that DC, that's a side, is congruent to BC. That's another side. So DC is this guy, BC is this guy. So we have those 2 matching up like that, DC and BC. Okay, that's given to us. We don't even have to work for it. It's all given. So that's all my given information. That gives me another side, right? So we have an angle and a side. So we either need another angle or another side. Right? We either need another angle or another side. Okay, so now what? We need another angle or another side. So looking at what's left.
Angle D
Angle B.
We don't know angle D and angle B for sure.
Angle C. Oh, C, yeah.
C. C is the same as C, right? This angle C is the same as this angle C because they're shared in the diagram. Do you see that?
Yeah.
Okay. This is the first time that we've done this where we have angle C is congruent to angle C, and that is the reflexive property. That's the first time that we've done the reflexive property for angles. It works for angles just the same way as it does for sides, right? Normally we're used to doing AB and AB or something like that, but angle C and angle C are the same angle C, right? Reflexive property, done. That is an angle? Okay, so now we have to decide. In my inventory, it looks like angle, side, angle. Okay, let's decide. Is it angle, side, angle? So we have this diagram up here. Is that angle, side, angle, or is that angle, angle, side?
Side, angle, angle. Angle, angle, side.
Right? So the angles that we have are A and C, right? If we had angle, side, angle, this would have to be the side right here, right? Okay, but it's not that one. So it's angle, angle, side, right? So angle, angle, side, or side, angle, angle. So angle, angle, side, and this is triangle ACD is congruent to triangle ECB by angle, angle, side, and we are done. So we say that those two triangles are exactly the same.
Let me guess who just walked
Beautiful, beautiful. Luke just walked in. That was the whole, oh, are you kidding me? So,
Can I have my test?
yeah, hold on just a second. We're almost done with this video. Okay? All right, so we're going to skip example 4. And then this bottom part right here is just a summary of all the ones that work. Okay? We will eventually write those down on your blue sheet so that you can use this on the test, but we'll just wait for that. Okay? And you guys have the homework sheet. Skip the 2's. So 2 on the one page, skip that 2, and skip 2 on the second page. Skip the 2's. Skip just 2 on each, like just the number 2 on each side.
You know,
There you go.
that one
Skip
was
the number
worst
2 on
one,
each side.
Number 4.
What?
That was the only one that I needed help on.
Number 4 was just a touch tricky. So anyway, there's that. Okay? All right, there is that. Good? Anything else to add before we close the video? Bye, Libby.